Hello everyone, welcome to Physics online classes for class 12 students. Let us continue chapter 6 Electromagnetic Induction. Today we are going to study about magnetic flux. Yes, dear students, we studied Faraday and Henry experiments in the previous classes. You can remember, after studying these three experiments, we came to know that whenever magnetic field changes, then only induced EMF takes place. That means when magnetic field linked with that coil changes, then induced EMF takes place or current is produced. This is the conclusion we came to know after studying three experiments. So now we are going to study about magnetic flux, which is related to Faraday and Henry experiments. Remember, conclusion of that three experiments are itself Faraday's laws. About Faraday's laws you are going to study later. Now before going to study about those laws, first we have to know what is magnetic flux. Now let us start the class. Let us study about magnetic flux. Observe the given points here. Faraday developed a quantitative theory of induction now called Faraday's law. We already studied Faraday and Henry's three experiments. After studying these series of experiments, he had given a quantitative theory of induction, theoretical part of induced EMF. And now we are going to call it as Faraday's law. About Faraday's law you are going to study later. The law shows how to calculate the induced electric field in different situations. So after studying Faraday's law, that law gives you how to calculate induced electric field, induced EMF in different situations. That is given by Faraday's law. Faraday's law uses the concept of magnetic flux. Yes, before going to study about Faraday's law, we have to know what is magnetic flux because the concept of magnetic flux is used in Faraday's law. And magnetic flux is similar to the concept of electric flux. Yes, in the first chapter you studied about electric field and electric flux. Magnetic flux is also having the same concept as electric flux. If you know about electric flux, then it is easy to understand magnetic flux, right? Magnetic flux is similar to the concept of electric flux. Yes, then how to define magnetic flux? Observe this definition here. The number of magnetic lines of force passing through an area normally, then we are going to call it as magnetic flux. Flux means flow. These magnetic lines of force are passing through a given area normally. Normally means perpendicularly. When these magnetic lines of force are passing perpendicular to the given area, then we are going to call it as magnetic flux. Yes, what is magnetic flux? The number of magnetic lines of force passing through an area normally. Then what is electric flux? You already studied in the first chapter. The number of electric lines of force passing through an area normally. In electric flux, we considered electric field lines. In magnetic flux, we are going to consider magnetic field lines or magnetic lines of force. If these magnetic field lines are passing through the given area perpendicularly, then we are going to call it as magnetic flux. Is it clear? Yes, what is magnetic flux? The number of magnetic field lines passing through an area normally. This is called magnetic flux. Now, we are going to take magnetic field lines. Here you can observe this picture. Vector B. B indicates magnetic field. What is B here? Magnetic field lines or magnetic lines of force. Magnetic flux is denoted by phi. Phi B. Pi B. If it is pi E, then it indicates electric flux. If it is denoted by pi B, then it is magnetic flux. As pi B indicates magnetic flux Vector B indicates magnetic lines of force or magnetic field. A is what? The given cross-sectional area. What is the equation here? Pi B equal to BA cos theta. Observe here. If that field makes an angle theta with the normal to the surface, you can observe the picture. Where is angle theta? Theta is between magnetic lines of force and normal which is drawn to the surface. Remember, always we have to consider angle between magnetic lines of force and normal drawn to the given surface. That gives angle theta. Is it clear? The equation is pi b equal to BA cos theta, or we can write B dot A. Pi b equal to B dot A. What is pi b? Pi b is magnetic flux, which is equal to magnetic field lines into cross-sectional area. Right? Pi b equal to B dot A. This is a dot product, or we can call it as cross product. If there is a dot product, then we can use cos theta. Trigonometric function cosine we have to use. You already studied. Pi b equal to B dot A or BA cos theta. Theta is angle between magnetic field lines and normal drawn to the given surface. When you are going to consider a plane surface, for that surface I am going to consider a normal. Normal means the line perpendicular to the surface. That normal and the magnetic field lines which are passing through that surface. So that angle we can take it as theta. What is the equation? Magnetic flux pi b equal to B dot A or BA cos theta. Now you can observe the second picture. Yes, if the field is perpendicular to the surface, observe the diagram. All the magnetic field lines are passing through this surface perpendicularly. If they are perpendicular to the surface, then the equation becomes, what is the value of theta when they are perpendicular to the field? Observe the second diagram. It is not equal to 90 degree. It is equal to 0 degree. Why? Because theta is angle between magnetic field lines and normal drawn to the surface. Normal means perpendicular line. Here, the line perpendicular to the surface and the magnetic field lines are also perpendicular. If both are perpendicular, then theta equal to 0 degree, not 90 degree. Is it clear? When theta equal to 0, then cos 0 will be how much? 1. Cos 0 is equal to 1. Remaining is what? Pi b equal to B into A. BA cos theta. Theta is 0 degree because the theta value, that is angle between magnetic field lines and normal drawn to the surface, both are perpendicular. So it is equal to 0 degree. Cos 0 is 1. So we got pi b equal to B into A. Then now you can observe one more picture. Observe this diagram. Here magnetic field lines are passing through the surface parallelly. Magnetic field lines and the surface both are parallel to each other. Now tell me what is the value of theta. Here theta is angle between magnetic field lines and normal drawn to the surface. So both are perpendicular. So it will be 90 degree cos theta or theta equal to 90 degree. Cos 90 is 0. 0 into BA will be 0. If the field is parallel to the surface, then magnetic flux is 0. These two conditions you have to remember. What is magnetic flux? The number of magnetic field lines passing through the surface normally is called magnetic flux. Magnetic flux is denoted by pi b. Flux means flow, right? Then equation is pi b equal to B dot A dot product. So we can write BA cos theta. Theta is angle between magnetic field lines and normal drawn to the surface. The first condition, if magnetic field lines are perpendicular to the surface, then equation is pi b equal to b into a because theta is 90 degree. In the second case, if magnetic field lines are parallel to the given surface, then theta equal to 90 degree, cos 90 is 0, 0 into anything will be 0. So magnetic flux pi b equal to 0. So these two conditions you have to remember. Yes, observe these points. The magnetic flux can be defined for any surface. You can consider any type of surface. Here, in that, if the surface is complicated, a complicated surface that can be broken into small regions and the definition of a flux applied. Remember, magnetic flux can be applied to any type of surface. But if the surface is complicated, then that surface you can break or that can be broken into small pieces and then you can apply the definition of magnetic flux. So when you applied magnetic flux for small regions of that complicated surface, then we have to take the total flux is sum of the fluxes through all the individual pieces of the surface. Suppose if I am going to consider one complicated surface, I am going to divide that surface into three pieces, three regions. Now I applied magnetic flux definition to all the three regions. After that we can take total flux. Total flux is what? Sum of the flux which is applied for individual regions of the surface. Then second point, the unit of magnetic flux, which is very important. The unit of magnetic flux, SI unit is Weber or Tesla meter square. What is the SI unit of magnetic flux? Weber or Tesla meter square. And its Celsius unit is Maxwell. 1 Weber equal to 10 raised to 8 Maxwell. 1 Weber equal to how many Maxwell? 10 raised to 8 Maxwell. So 1 Weber equal to 1 Tesla meter square because Weber and Tesla meter square both are the SI unit of magnetic flux. Then this magnetic flux is a scalar quantity. It is not having a definite direction. That's why it is a scalar quantity and its dimensional formula is ml raised to 2 t raised to minus 2 a raised to minus 1. So this is all about SI unit, Celsius unit and dimensional formula of magnetic flux. Now let us observe some MCQs related to magnetic flux. Yes, the question is, the number of lines of force passing through an area in a magnetic field is known as. Yes, this is known as option A, magnetic induction, option B, induced current, option C, magnetic flux, option D, magnetic field. Yes, what is the question? The number of lines of force passing through an area in a magnetic field, and this is known as magnetic flux. This is the definition of magnetic flux. Then, second question, the unit of magnetic flux is options Weber, Tesla meter square, both A and B, Tesla. Yes, Weber, Tesla meter square, both are the SI unit of magnetic flux. That's why both A and B are the right answers. Option C is right. Yes, this is all about magnetic flux. In the next class, we can study about Faraday's laws.